2025, our sun awakens like never before. Powerful solar storms loom on the horizon, threatening technology, communication, and our very way of life. Welcome to our in-depth exploration of the 2025 solar storms. In this video, we will journey through the scientific mechanisms of solar flares and CMEs, examine the precise forecasts for 2025, confront ancient prophecies pointing to catastrophic sun events, and ultimately ask, are we prepared for what's coming? Our sun operates on an approximately 11-year cycle, a rhythmic pattern of solar activity that directly affects life on Earth. During the peak phase of this cycle, known as solar maximum, sunspots proliferate dramatically on the sun's surface. These sunspots appear as dark regions, intensely magnetic and cooler than their surrounding areas. Yet paradoxically, they serve as the powerful epicenters for some of the most dramatic solar phenomena we observe. It is within these sunspots that immense magnetic tensions build, twisting and contorting magnetic field lines like tightly wound springs. Eventually, when these field lines can no longer sustain the tension, they abruptly snap. This explosive reconnection releases enormous amounts of energy, manifesting as a solar flare, an intense burst of radiation primarily composed of X-rays and extreme ultraviolet light. Occasionally accompanying these solar flares are colossal eruptions known as coronal mass ejections, or CMEs. These events propel massive clouds of charged solar plasma, consisting of billions of tons of particles, outwards into space, traveling at staggering speeds ranging from 1 to 2,000 kilometers per second. These CMEs can significantly influence planetary environments, including our own. When solar flares occur, their radiation reaches Earth almost instantaneously. This surge of energy interacts swiftly and powerfully with the upper layers of Earth's atmosphere, specifically ionizing the D layer of the ionosphere. As the ionosphere's ionization intensifies, it absorbs high-frequency radio waves, causing immediate and widespread communication disruptions known as HF blackouts. During these events, radio communications, essential for aviation, maritime navigation, and emergency services, can vanish entirely, creating sudden and serious operational challenges. The impact of CMEs, though slightly delayed, is no less severe. Arriving hours to days after the initial flare, these massive clouds of charged particles collide with Earth's magnetic field, generating powerful geomagnetic storms. These storms pose significant threats, endangering satellites critical to communication, navigation, and weather forecasting, and potentially crippling power grids. History has already demonstrated the destructive potential of such solar phenomena, underscoring the need for vigilance and preparedness as we approach the next solar maximum in 2025. Understanding and preparing for these events is not just a scientific endeavor. It is essential for safeguarding our modern, technology-dependent society from potentially catastrophic disruptions. In early 2025, all eyes turned toward the sun as space weather activity surged. Data from NOAA's Space Weather Prediction Center revealed alarming trends. The Wolf number, an index tracking the number and size of sunspots, climbed sharply, surpassing 130. Meanwhile, solar flux readings soared beyond 115 solar flux units. These are unmistakable indicators that solar cycle 25 is rapidly approaching its peak. Among the many active regions scattered across the solar disk, one stood out: sunspot region AR 4087. This particular region had been displaying increasingly volatile behavior. Then, on May 13th, AR 4087 erupted with an X-1.2 class solar flare. The blast sent a surge of X-rays and ultraviolet radiation hurtling toward Earth. But the activity didn't stop there. Just hours later, in the early morning of May 14th, the same region unleashed an M5.3 class flare, further intensifying concerns among space weather scientists and operators of critical infrastructure. Then came the event that truly captured global attention. At precisely 8:25 UTC on May 14th, AR 4087 ignited with an X-2.7 class flare, the most powerful flare recorded so far in 2025. The eruption was monumental. Within minutes, a torrent of high-energy X-rays and extreme ultraviolet radiation reached Earth, racing ahead of any potential coronal mass ejection. The sudden influx of radiation ionized the D layer of Earth's ionosphere. This rapid ionization triggered immediate consequences. High-frequency radio blackouts spread quickly across vast regions of the globe. In Europe, Asia, and the Middle East, aviation and maritime operators began reporting unexpected communication failures. Pilots and air traffic controllers struggled with degraded signals. Ships navigating busy maritime routes faced similar challenges. These sudden disruptions served as a stark reminder. Despite all of humanity's technological advancements, our modern world remains deeply vulnerable to the whims of our closest star. As solar cycle 25 surges toward its peak, experts caution that even more intense flares and geomagnetic storms may lie ahead. The events of May 2025 may be only the beginning. Beyond radio blackouts, the effects of solar storms ripple across modern technology in ways that few might expect. As solar radiation intensifies, increased ionization in Earth's upper atmosphere distorts GPS signals. Under normal conditions, GPS accuracy can be pinpointed to within a meter. But during heightened solar activity, position accuracy can drift, sometimes by tens of meters. This presents serious challenges for aircraft navigation, precision agriculture, maritime operations, and even emergency services that rely on accurate geolocation. Meanwhile, satellites in low Earth orbit face another threat: heightened atmospheric drag. The influx of solar energy causes Earth's atmosphere to expand outward, pushing into the orbital paths of these satellites. As a result, satellites experience increased resistance. Without corrective action, they begin to lose altitude. To counter this, operators must initiate emergency thruster burns to maintain proper orbit, a costly and delicate maneuver. But the dangers extend far beyond orbit. When a coronal mass ejection, an immense cloud of charged particles, strikes Earth, it can trigger geomagnetic storms. These storms induce powerful electrical currents within Earth's crust. Such currents, known as geomagnetically induced currents, or GICS, can infiltrate long-distance power grids. History offers a sobering example. In March of 1989, a strong geomagnetic storm caused Quebec's power grid to collapse in just seconds, leaving millions without electricity. The event served as a wake-up call. Today, utility companies worldwide are taking precautions, installing GIC blockers and reinforcing transformers to withstand surges that can exceed thousands of amps. Still, the risk remains. Space travelers are not immune either. Astronauts aboard the International Space Station face elevated radiation levels during intense solar storms. In extreme cases, crew members may need to shelter in shielded areas of the station until radiation subsides. Even here on Earth, aviation is affected. Pilots flying polar routes, favored for their efficiency, may encounter dangerous radiation spikes. During major storms, airlines often reroute flights away from polar regions, trading time and fuel for passenger safety. And while many impacts are hidden from view, some are spectacularly visible. In high-latitude regions, geomagnetic storms ignite breathtaking auroras. Curtains of green, purple, and red light ripple across the night sky, a mesmerizing natural display, but also a vivid reminder of the sun's awesome power. As we look toward the peak of solar cycle 25, these risks serve as both warning and inspiration. Humanity's intricate web of technology is tethered to the whims of a star 150 million kilometers away. Understanding and preparing for this connection is more vital now than ever. Throughout history, civilizations have watched the sun with reverence and with fear. Among the ancient records, inscriptions from the Maya stand out. These enigmatic texts speak of a great awakening of the sun, a period when the sun's power would surge every 1,000 years. Though the language is cryptic, modern scholars believe the Maya were keen sky watchers, meticulously observing solar behavior over centuries. Some theorize that they may have identified long-term solar cycles, patterns echoing through myth as warnings of solar cataclysms. Could the upcoming solar activity in 2025 resonate with these ancient visions? The question remains open to interpretation. In modern times, apocalyptic predictions find new life online. On platforms like YouTube, New Age channels have seized on the 2025 solar maximum, promoting bold and alarming claims. Many warn of an impending global grid down event, in which an unprecedented solar storm will supposedly obliterate all electronics, satellites, and global communications, plunging civilization into chaos. Such narratives spread rapidly, fueled by a mix of ancient prophecy, modern anxiety, and digital sensationalism. Yet while these stories captivate audiences, they often lack empirical grounding. The dramatic flair may stir emotions, but without scientific data, these predictions remain speculative at best. By contrast, the scientific community relies on rigorously tested forecasting methods. Using sunspot counts, advanced magnetic field models, and continuous satellite observations, experts can track and predict solar activity with remarkable accuracy, often within a margin of days. These tools provide critical warnings, enabling power grid operators, aviation authorities, and satellite controllers to take preemptive measures. In this way, science and prophecy stand in sharp contrast. Prophecies offer vivid imagery and cautionary tales, but they do not provide precise dates or measurable indicators. Science, grounded in data, equips us with actionable insights, vital for protecting our interconnected world. Still, it's worth noting that both serve a role. Prophetic traditions remind us of humanity's long-standing awe of the cosmos and the importance of humility before forces beyond our control. Science empowers us to act, bridging ancient wisdom with modern preparedness. As we approach the peak of solar cycle 25, separating fact from fiction will be crucial. In a time of heightened solar activity and heightened online noise, discernment is our best ally. Looking ahead, solar activity in 2025 shows no signs of slowing. Beyond the recent X 2.7 class flare from region AR4087, scientists are closely tracking the emergence of a new sunspot group, AR4102, expected to appear by mid-year. Forecast models suggest that AR4087 isn't done yet. As it rotates back toward a more Earth-facing position in June, The region carries roughly a 50% chance of producing an even more powerful X3.0 class flare. Meanwhile, AR4102, as it matures, presents a 35% probability of launching an X2.0 class event by September. Such flares aren't just bright flashes. They often come paired with massive coronal mass ejections. Each CME from these potential flares could trigger geomagnetic storms of G3 to G4 intensity on the NOAA space weather scale. These storms carry the power to disrupt satellites, power grids, aviation, and communication systems on a global scale. In response, space agencies worldwide are advocating for enhanced early warning capabilities. Satellites like DSCO-VR and ACE, stationed at the L1 Lagrange point between Earth and the Sun, provide crucial advance notice, detecting CME signatures hours before they strike our planet. For utility providers, this warning window is vital. It gives operators precious time to activate GIC blockers, devices that prevent damaging geomagnetically induced currents from surging through power grids. Critical transformers are also being reinforced to withstand potential electrical overloads that could otherwise result in widespread blackouts. Satellites themselves require special preparation. Engineers have developed radiation-hardened electronics designed to endure extreme solar conditions. Additionally, modern satellites are programmed with autonomous safe mode protocols, allowing them to temporarily shut down vulnerable systems and ride out the storm. But preparation isn't limited to governments and industry. Individuals and businesses alike should take proactive steps. For homes, surge protectors can shield appliances and electronics from sudden voltage spikes. Backup power generators can keep essential systems running during outages. Businesses must also safeguard their digital infrastructure. Servers should be connected to uninterruptible power supplies, and critical data must be backed up, ideally offline, to prevent loss during extended disruptions. Staying informed is equally important. Official space weather apps provide real-time alerts on incoming flares and potential high-frequency radio blackouts. Monitoring these updates can make a critical difference. For aviation, special caution is required. Airlines and pilots flying polar routes must remain vigilant. During peak solar activity, rerouting flights away from polar corridors may be necessary to avoid communication outages and elevated radiation exposure. As the sun's activity intensifies through 2025, a layered defense, spanning technology, infrastructure, and personal readiness will be key to resilience. Awareness and preparation remain our best tools in facing the storms to come.